Hi, this is Sammy again. Today what we will be doing trigonometry with right angle triangles. So basically right angle triangles, you know, the sine, cosine, tangent, and a lot of you heard the word Soh Cah Toa, which is the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. I think a lot of students when they start working with this, they're not sure what they're looking for. You know, are you looking for the angle or are you looking for the sides? There are two examples, basically examples that they don't give you any angles except for the 90 degrees and they want you to find angles. And the other examples, they give you an angle and a side and they want you to solve the whole triangle. So stay tuned for that. So there you go, right angle triangle, trigonometry. The thing is, we learned about Soh Cah Toa, sine, theta just a symbol that we use for angles. So sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And tan theta equals opposite over adjacent. So here's some trig questions. And basically in trig, these are the two situations with right angle triangles that they will always get. So the first one right here, which is they give you a triangle and they say solve the triangle. When they say solve the triangle, that means you have to find everything that's missing in the triangle. So here what's missing? This angle here is missing. The length of AB is missing and the length of AC is missing. So in this situation here, you want to start with finding one of the sides. The first thing you want to look at which angle you're working from. So I'm working from this angle. Yeah. So if I'm working from this angle here, I'm going to say, okay, if I want to find AB, I'm just going to call it little c because it's opposite to C. And this side, I'm going to call it little b because it's opposite to B. So that we know what we're talking about. So if I want to find the length of C, now I look at this angle here. Now the unknown C with respect to this angle is adjacent. And what we are given, the 7, it's opposite. So that function that involves opposite and adjacent is tangent because tangent Toa means opposite over adjacent. So to find C, I'm going to go tan 35 equals opposite, which is 7, over adjacent, which is C. Now, anytime your unknown is on the bottom, what you do, you switch the C and the tan 35. You cross the C this way and you cross the tan 35 where the C is. So you'll end up with C here equaling 7 over tan 35. And that after that, basically just go to your calculator, make sure you're in degree mode. You go 7 divided by tan 35 equals, and it gives you 9.99. So I'm just going to say C here, C equals 10. Now, once we found out C to be 10, I could either use Pythagoras, 10 square root of 10 squared plus 7 squared equals B, or just since we're doing trig, let's just practice more trig. So now it's angle 35, this is the opposite, and B is the hypotenuse. So I'm going to use sine because sine involves the opposite over hypotenuse. So what I'm going to do, I'm going to say sine or sin 35 equals the opposite, which is 7, over the hypotenuse, which is B. Now, again, since your unknown is on the bottom, you just cross exchange or switch where the B goes to where sine 35 is and sine 35 comes where B is. And that way you're going to get B equals 7 over sine 35. And that will give you 12.2, or just round it to the nearest centimeter. So B equals 12. So this is 12. Now, how about angle C? Angle C, you know, the sum of angles in a triangle is 180. Okay. But when it's so you could go 180 minus 90 minus 35 to find angle C. But every time you have a 90-degree triangle, you don't have to go 180. The shortcut to find angle C is to go 90 minus 35. Since this other angle is 90, that means this 2 also will add up to 90 to make up 180. So you could take a shortcut with right angle triangles. When you're finding the third angle, you just go 90 minus 35, and that will give you 55 degrees. Now we will go to this green triangle and find out whatever is missing. So basically here we're going to find out what angle X is, what angle Z is, and also what side X, Y is. So the side opposite to angle Z, I'm just going to call it little z here. And the side that's opposite to X, well, it's already given there. So we just, here's the Z that I'm looking for. So I could use Pythagoras, and I could say Z here equals, you know what, I'm just gonna draw a line here just to show that we're starting a new question here. So there you go, Z would equal square root of 5 squared minus 2 squared. I remember when I told you about Pythagoras, if you're finding a side and not the hypotenuse, then you just go the square root of the hypotenuse squared minus the given side squared, and that's 25 minus 4, which gives me 21. So Z is going to be just square root of 21. So that's going to be root 21. Now let's find one of the angles. So which one I want to find? You want to find the Z or the X? Okay, I'm just going to go find the X. So with the X, I'm given the opposite side and the hypotenuse. So now you go sine X, because opposite and hypotenuse involves the sine function. Sine X, which that angle right here, equals the opposite over the hypotenuse. And to find angle X, what you want to do, you want to go second function sine, and that gives you something like this on the calculator, of 2/5. Put that in brackets, and that will give you what the angle X is. So just second sin 2/5 gives me 23.5. So I'm just going to round to the nearest degree. So that's going to give me X is 23 degrees. What I notice mistakes that students make once they find the angle, they write sine X equals 23. No, sine X does not equal 23. Sine X equals 2/5, which is 0.4. It's angle X that equals 23 degrees. So just make sure you understand the difference. You know, when we say sine, basically the sine means the ratio of the opposite side to the hypotenuse of that angle, but the angle is 23 degrees. Once you find that angle to be 23 degrees, and you don't want to do any more trig after that, you could just go angle Z would equal 90 degrees minus 23 degrees, which gives me 67 degrees. So this is 67 degrees.